Hi everyone, I'm making you this video on why there are two sexes for two reasons. One is it'll save us time in class to talk about hard hormone things. And second, it's the kind of thing that kind of blows people's minds, and so it's nice to have it available to watch more than once, unlike class. So the question that we're addressing in this little video is why are there sexes? So not why there's sex, because that's a different question, why sex exists instead of animals reproducing asexually. This question is, given that animals reproduce asexually, combining genetic material from two different individuals, why can't all individuals combine their gametes? Why do there need to be two different types of animals which can only combine their gametes with the other kind? You might assume that's just the way it works, but it's perfectly reasonable to imagine a situation, especially if you remember the animals evolved in the ocean and you picture aquatic animals. If you picture two jellyfish releasing their gametes into the ocean, why can't any two of those gametes meet and form a new offspring? Why do there need to be different kinds meeting together? So, in order to really understand why there are males and females, we have to know what is a male and a female. So the question that I was going to ask you in class about this is simply, what's a female? So I invite you to pause the video here and think about what you think the answer is. I know many of you won't pause the video, but those who want with their heart to learn the most will pause it. Okay, I hope you paused it so you can learn more. A says the sex that has the lower testosterone levels. Only vertebrate animals have testosterone, so the vast majority of animals are invertebrates. They don't have testosterone. This can't be the difference between male and female jellyfish, male and female dragonflies, anything like that. So that can't be it. B says the sex that takes care of the offspring. This is by far a tinier percentage of animals. Far less than 1% of all animals have any parental care of any kind. In most cases, neither male nor female parent has any care for the offspring. C, the sex that houses the developing fetus. Again, in the vast majority of cases, there is no housing of the fetus. Only in mammals and a few other species do you see that. So this can't be the difference between male and female spiders, male and female guppies, anything like that. D, the sex that makes the bigger gamete. That's what's left, so you can tell by process of elimination that it's correct. But the key is to realize that this is the thing that defines males and females. The difference, and the only thing that is consistent across all groups of animals, is that females make bigger gametes. An egg is a large, well-supplied gamete, and a sperm is a small gamete, sometimes mobile. Sometimes eggs are mobile too, but sperm are more likely to be mobile because it's easier to move small things to big things, and for other reasons that we'll see. So that's it, and that is a difference that applies to cows, it applies to people, it applies to dragonflies, it applies to jellyfish, it applies to spiders. It is true in all of those cases, and actually is the thing that determines everything else then. So why is it that females are the ones who are stuck housing the fetus in those species that do that? Because they're the one that made that big gamete to begin with. It's a lot harder to move. So you have to move the small thing to the big thing, and there you end up with the fertilized egg in the female. So, why are males often more willing to seek multiple mates in many species than females are? Because each offspring is a much bigger investment for a female animal. So it's important that she be very careful about how she's going to spend that investment. Whereas for males, each individual gamete or set of gametes is a relatively small part of his total reproductive investment. And therefore, it makes more sense to have as many individual investment events as possible and not to be too careful, essentially. No, there's no need to be very picky about any individual one. And there's lots of other things that we can talk about in that vein, but we're going to move on. All right, so now you have to imagine a situation before sexes, when there were just gametes that were all the same size. It's probably easier if you picture an aquatic animal, right? So imagine, as it's shown on the slide, a fish that's releasing gametes, and they're not sperm and they're not eggs, they're kind of in between, all right? And all the fish make them, and they can join together and make new fish that are neither male nor female, they're just these fish, okay? No sexes in this fish. So we know that the only way evolution works is variation, right? There has to be variation in whatever trait you're selecting on. So it seems reasonable that by chance some of these gametes that the fish made would be smaller and some of them would be bigger. So imagine if some fish happen to make quite small gametes, smaller than usual, maybe half as big or less than the average size. Now this is not, as shown in the little cartoon thing, this is not how evolution works, that the fish is thinking, if I made smaller gametes I could make more babies. But it is the case that that individual could make more babies if they made smaller gametes, because with the same amount of investment of energy, if they made them smaller, they would simply have more energy left over to make more of them. And if all of those gametes were able to fuse with the gametes of another individual, then they would result in more offspring. So in a sense, an animal would have an advantage, right, if they made smaller gametes. Now, there's also an advantage to making big gametes, right? If we go here and we say, well, what if this individual made big gametes? Just by chance, again, right? The cartoon is kind of a joke there. That's not how evolution works, but it's the way you can sort of think about it. If that individual made bigger gametes, then that would be good too, because then the combination, once they combined with another individual's gamete and started to develop into a new fish, that fish would be pretty likely to survive and reproduce compared to others, because it would have more energy, right? The egg has that additional energy. Well, not an egg yet, but that larger gamete has that additional energy in it and would provide a better start in life for that individual. So it's an advantage to make small ones. It's a different kind of advantage to make big ones. And now the last step is that if you have this fish here, and another thing that's available for selection is behavior, right? And if this fish develops a preference, right, for this fish that makes small gametes, the ones that happen to have a preference for choosing as a mate fish that make large gametes are going to be selected for, right? Because then they get to make lots of gametes like they wanted to in the first place, and their offspring will be well supplied and more likely to survive because they have that energy source from that large gamete. So any individual that made small gametes that also had a preference for animals with large gametes would be selected for. And eventually, so this is the cartoonish way to put it there, right? And as that happened then, divergent selection occurred, and that's the term you heard before in 142, but it's been a long time, such that animals that made medium-sized gametes were no longer of any particular value compared to the ones that made small gametes that win because they make a lot of offspring, and animals that made large gametes that win because A, they have well-supplied gametes, and B, they're attracting a lot of mates, these smaller ones that want to mate with them. So then you end up with two sexes. It's a really neat story, and a story we don't tell enough. So if you have any questions about that, let me know. And now that it's in video form, you can also just rewatch it. See you soon.